Okay, so today we're going to go on to Unit 4. Unit 4 is Chapter 6. This is Lesson 6.1, Reflection Symmetry. The big idea is that basic figures of geometry all have reflection symmetry. And then we're going to answer three basic questions. What is reflection symmetry? How does it pertain to angles? And how does it pertain to circles? We're also going to look at segments too. So the first thing is, let's look at what reflection symmetry is. Okay, so this is just straight out of your book. It says, what is reflection symmetry? I've underlined the part that's important there. When a figure is reflected over a line, there are times when the figure will coincide with its image. And if you look at the lion's face here, and then you look at an outline of the lion's face, you can see that the reflection symmetry line can go right down the middle, and it sort of divides the face into two congruent parts. They're just reflected over each other. There's an ear on each side, there's an eye on each side, half of the nose is on each side. So this would be said to have one line of reflection symmetry. Here is the definition out of the book. You can read that on your own and figure it out. Down here is a trapezoid. This one happens to be an isosceles trapezoid, and with this isosceles trapezoid, it has a line of symmetry that goes straight through here. And this line of symmetry gives me two halves of the trapezoid that if I would fold on this line, then the two halves would fall on top of each other. They would be exactly the same. This half of the trapezoid is a reflection of this half of the trapezoid. This line is called the line of reflection symmetry. Okay, so the first thing we're going to look at is the reflection symmetry of segments. Normally, most of us would think a segment only has one reflection line, and that reflection line would be the perpendicular bisector of that segment. So it would be the line that would go down through here at a 90-degree angle and cut the segment perfectly in half. A segment also has a second symmetry line, and it is the line that contains the segment. So in other words, if I would put a line through here that contained the segment, so I'm going to put a line right through it. Didn't do such a good job there, but if I would put the line right on top of this, let's go back and try again. If I would get the line right on top, this would be a line of reflection. Okay, I know it seems a little counterintuitive to what you would normally think, but a segment does have two lines of reflection. One's a perpendicular bisector, and the other is the line that contains the segment. This is an activity. We're going to do some activities with Geometer Sketchpad in class tomorrow. So here what we're looking at is the reflection symmetry of angles. And again, if you think about what reflection symmetry is and what an angle bisector is, you would understand that the line of reflection is also going to be the angle bisector, because whenever you do a reflection line, you're going to have exactly the same thing on both sides. So if I'm going to do an angle bisector, I'm going to have the exact same measure on both sides. Now notice that this ray appears shorter than this ray, but if you remember, rays go on and on and on forever, so it doesn't really matter that this one appears shorter than this one. They are still going to be a reflection of each other. Here they call it the side switching theorem. If one side of the angle is reflected over the line containing the angle bisector, its image is the other side of the angle. So in other words, if I would fold this on the angle bisector line, I would have pieces that would fall right on top of each other. And if you were looking through tracing paper, it would appear that you only had one image. And then the third one is symmetry of a circle. you can't draw all the symmetry lines of a circle, because all the symmetry line of a circle has to have is going through the circle, through the center. So I could draw a number of symmetry lines. I could draw one down through there. As long as it goes through point O, it's fine. I could draw one there. I can draw one here. I could draw one here. As long as it goes through the center of the circle, a circle has many, many, many lines of symmetry. In fact, it has an infinite number of lines of symmetry. So those are the big ideas I'd like for you to understand from Chapter 6, Section 1. Okay, now go to the questions part of Ed U 2.0 and answer the questions that are there.